Good morning, and I'm gonna do a quick video to help you get through some tips and tricks. Okay, so 2.3 measures of central tendency. This is stuff you kind of already know. So again, this isn't going to be really stressful. We've already gone through these. We're going to hit this one today in our unit. And mean, median, and mode is stuff that you should know. Weighted mean is the same idea as a GPA, grade point average. And then shapes of distributions. They could be symmetric, uniform, or skewed. And we'll talk about how that works. So we've got some guided notes that you can be filling in as you want. And at the top of that, it says measure of central tendency. And it's a value that represents some general idea, some patterns of what's going on. In the fill in the blanks, you're going to fill in it's a number to help describe patterns in a group of data. And the most common measures of central tendency that we ever use is mean. What it is, it's an average. How to do it, you add them together and divide by how many there are. Median is the middle number, and that's what it is. And how you do it, you put them in order and look at the middle. If there's two numbers in the middle, though, you're going to have to find their average. Mode, what it is the most, the number that shows up the most. And then how to do it, you just look to see which one is repeated the most. And then outlier. Outlier is a number that's very different from the rest. It's kind of like the weirdo on the outside. Outside, it lies outside. So for now, we're just going to look at numbers that are far away from the rest. Later on, we're going to learn some fancy details. In that next box on your guided note sheet, it's got this weird symbol. And what we call it is sigma. And I already wrote that in there for you. What it is the summation symbol. And it's a Greek letter. It's a Greek capital letter for S. And if you ever hear of sororities and fraternities, there's a lot that have sigma in there because that's a Greek letter. And how you do it is you add up the numbers. That's all it means. If they put this in there, they're saying add up some numbers. So if they have sigma x, that means add all of the x's that are in the data set. Okay. Mean, now there's two versions of mean or average. There's the sample mean, and we use this symbol. So X bar is how we say it, and I already wrote that on the chart for you. What it is, it's the sample mean, and the one under it, we pronounce this mu. What it is, it's the population mean. So this is the average of the sample. This is the average of the population. So what we call it, X bar, it's a symbol for sample mean. What we call it, mu, it's another Greek letter. And it's the lowercase Greek letter for M, and it's a symbol for mean of a population. So if I put this up there, or this, you know you're finding the average. And if I use this one as the average of sample, this one average of the whole population. So flip over your paper, and it says, which is better? Well, it depends. Sometimes there is no mode, so you're going to fill this blank in on your paper. And sometimes the data is bimodal or multimodal, meaning it has more than one mode. Often the mean is the most important, but it's easy to mess with. If you get an extra high or extra low value, like an outlier, it could move that average a lot. For example, if you think about the average age of the students in the room, and then suddenly if you throw in Miss Flannery's age, that's going to make that average go way up higher. And so it's easily messed with. Now, median is one that people like a lot because it's more resistant to outliers. So if I put an outlier in, it's not going to move the median very much, which is helpful because it's about position and not value. All right, so when we're comparing them, here's an example real quick. Find the mean, median, and mode of the ages. Are there any outliers? Which measure of central tendency best describes it? So here's the ages in a class. Now look, it looks like these are high school or college age students and then maybe the professor, right? So to find the mean, you add them all up, but there's a cheat way to do this in Desmos, and I'll show you that in a second. You add them all up. To find the median, let me go back. You need to put them in order from smallest to biggest, and then you're going to look at the middle number. So we're going to look at, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 numbers in here. So the first 10 and the last 10. And so the middle would be right between these two numbers, right? The middle would be right between 21 and 22. So then you would add 21 plus 22. You have to find the average of those two since there's not a middle number sitting there. So we just do the average of those two numbers, and it's 21 and a half. Mode is just, you just look, which one shows up the most? What number in here keeps repeating? Well, there's a lot of the number 20. So in that case, the mode is 20. Are there any outliers? Which one of these numbers do you think is kind of weird? Well, I would say that 65. The rest of these are all in their 20s, and then there's that 65. Because that person is way older than everybody else. My guess is that's the professor. And it says, which measure of central tendency best describes a typical entry? Well, the mean is going to be messed with because of that big old outlier. So I don't think mean is probably the best idea this time. Probably the median. So let's look, if we did a frequency distribution, the mode is way over here at the beginning. That's not close to the middle. The mean is way over here at the end because that outlier pulls it out. So the median is looking like the best way to describe the middle in this one. And that's what central tendency means. So in this case, it appears that the median best describes this data. All right, weighted mean, the next box on your paper. Weighted mean is just if one thing counts more than another, right? If it's kind of like if I give you 5 coins, you care about which coin it is. Hopefully I give you more quarters than pennies, right? Because the quarters are weighted more. They count for more. They're 25 cents versus a penny being 1. So finding the average of them depends on how much each one is worth. And we use weighted mean to find your grade point average, right? An A is worth more points on your grade point average than a C, for example. So if we do an example here, finding the weighted mean, let's say last year you got 3 A's, 3 B's, and 1 C. So you can use the space on the right to do an example here. Calculate your GPA for that year. Okay, 3 A's. An A is worth 4 points. Oops. Each A is worth 4 points. Each B is worth 3 points. Each C is worth 2. D is 1, and F's are 0. That's how GPA works. So you got 3 of these A's. So you would do 4 times 3. Okay? You got 3 A's. So 3 of those A's, which gives me 12. And then we got 3 B's. So 3 of those B's, which gives me 9. And 1 C. So 1 of those C's, which gives me 2. 1 times 2 is 2, right? None of these don't matter. Then you're going to add all those up. So we add up the points, which was 23, and we add up how many grades you had. You had 1, 2, 3, 4, 5, 6, 7 grades. 1, 2, 3, 4, 5, 6, 7 grades, right? So then we take the points divided by how many grades you had, and we get 3.28, okay? Okay, so now on the bottom of your paper, we'll talk about different shapes of frequency histograms. And those shapes we call distribution shapes, frequency distribution shapes. And this little guy is sometimes also called the bell curve because it almost looks like an upside down bell, like Taco Bell. And in this one is called symmetric, or it's also called normal distribution or the bell curve. And you'll notice that the mean, the median, and the mode are all in the middle. So if you know your data is symmetric, it doesn't matter which one of these 3 you pick, they're all in the middle. This is if all the answers are the same or close to the same. and that's called uniform distribution. That's the second box on the back page, the 4 common shapes. And I want you to write down in that little box where it says information that the mean and the median are in the middle. And everything is a mode. Like, you only have really one answer, so you can't put a mode in here. It's all a mode. Sound like I'm talking about ice cream. A la mode, all the mode. And then down here we have what's called skewed left. Now, if you think about it, you can think of it like this is well, sometimes I draw a little dinosaur on here. I didn't this time, but a little dinosaur with the tail is on the left. The tail is on the left. All the data looks like it's squished to the right, and the tail is on the left because, that also known as negatively skewed. The reason they say it's left skewed is because it moves the mean to the left. In uniform, it's all in the middle. In skewed left, that mean gets squished to the left side. Skewed right, where the tail, the longer part, is on the right, like this is kind of steep, and then it kind of gradually tails off to the right. The mean gets squished over to the right, and that's called positively skewed. The tail's on the right, and it's called skewed right.